we'll be looking at stoichiometry. We'll be looking at mass to mass relationship. Mass to mass relationship. How you can use mass of one, whether reactant or product, to calculate the other mass. You can be given the mass of one to calculate the other one. Now let's check. Let's have an example. We have 50.4 grams of NaHCO3 was heated in a test tube. Was heated in a boiling tube. Was heated in a boiling tube until a constant mass of residual is got. The equation reaction is 2NaHCO3 to give Na2CO3 plus CO2 plus H2O. 1. Calculates the mass of Na2CO3 that would be produced. That will be produced as residue. That will be produced as residue at the end of the reaction. At the end of the reaction. Now, when we have a question like this, the equation solution, you write the equation first. The equation is 2NaHCO3 to give Na2CO3 plus CO2 plus H2O So we have to calculate the mass of Na2CO3. So the first thing to do is mole equals to mass over molar mass. So you calculate the mole of NaHCO3. So the first thing you do is to calculate the molar mass. In this, you compare the mole to mole. So the molar mass of NaHCO3. So we have 23 plus 1 plus 12 plus 16 times 3. So we have 23 plus 1 plus 12 plus 48. So this is 60, which is 84. So we have 84 grams per mole. 84 grams per mole. So when we are done with this, we now calculate mass. Mass is what? The mass is 50.4. You divide it by 84. So the answer that you have here, the answer will be a mole. The answer will be a mole. So once you are done with that, the next thing to do is to calculate. You compare the mole ratio. This in comparison to this. This in comparison to this. We have 2 mole of NaHCO3 to give us 2 mole. To give us 1 mole, you compare. The next thing, one thing in this mass to mass ratio is you first of all get your mole. Once you've gotten your mole, the next thing you do is to compare the mass to mass relationship. So for you to do that, you calculate your mole first. After you've gotten your mole, you now compare the mole of this to the mole of what you are asked to find. If what you have to find is CO2, you compare, but the mole that you have to find is 1. So we have it to 1 mole of Na2CO3. So the next one is what? The next one is 15.4 over 84. You can actually divide by, I'm not with calculator, mole of NHCO3 equals to S mole of Na2CO3. Please take note. The first thing to do is that you calculate the mole of the one given. You now compare the mole of the one given to the one you are asked to find. The first thing you do, you calculate the mole of the first one. You now compare it with the mole of what you are asked to find. So from here, you cross multiply. We have our x 2s equals to 50.4 over 84. So the next thing you do is what? You calculate your s. That will be s equals to 50.4 over 168. So your answer will be mole of Na2CO3. So when you are done with this, the next thing to do is you calculate the mass. We have mass. You calculate the mass. Mass equals to mole times molar mass. Times what? Molar mass. So we have molar mass of what? Of Na2CO3. So, which is 23 times 2 plus 12 plus 16 times 3. We have 46 plus 12 plus 48. So that's going to give us 106 gram per mole. So we just come here. And what mass are we calculating? Of Na2CO3. So mass of Na2CO3 equals to 50.4168 times 106. So you arrive at your answer. That's how to calculate mass to mass relationship. Mass to mass relationship. I'll give us an exercise. I'll give us an exercise to try. I'll give us an exercise to try. I'll give us an exercise to try. Exercise to try. I'll give us an exercise to try. So, we'll try this. What mass of sodium will be required to react with oxygen to produce 6.2 grams of sodium oxide. The equation of the reaction. The equation of the reaction. We have 4Na plus O2 to give us 2NaO2. 2NaO2. So try this. Thank you.